Welcome to the MS SQL Tips webcast, what you should know about high availability for SQL Server in AWS, sponsored by SIOS. I'm Greg Robidoux, co-founder of MS SQL Tips and the host for today's webcast. Our speakers today are Tony Tamarchio, who is the Director of Field Engineering for SIOS Technology, and Scott Zimmerman, who is a Solutions Architect with Amazon Web Services. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. In addition to today's event, we also invite you to check out all the free resources on mssqltips.com. If you're not already a member of the MS SQL Tips community, and we invite you to join, you can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Scott, and he can get started.
All right, good. Hello, everyone, and thank you. Just doing a volume check is okay. Give me a thumbs up if everybody can hear me okay.
Yep, you sound good, Scott.
All right, very good. Well, hello again. I'm going to start with some basic information, but as we go through my deck, and certainly as we get into Tony's deck, you're going to see that the slides get progressively more advanced. So let me go ahead and jump into this. First thing I want to start off with is, well, as you may know, AWS has two services where you can run Microsoft SQL Server. Amazon RDS, which stands for Relational Database Service, is a fully managed service that takes some administrative tasks off your shoulders, like backups and patching, but you still need to optimize your schema design and your indexes. Now, on the other hand, Amazon EC2, which stands for Elastic Compute Cloud, lets you run SQL Server where you have full control of the instance. We call it, when you launch a virtual machine in the cloud, we call that an instance. In either case, you can bring your own license called BYOL, or you can buy your licenses from AWS called License Included. For example, when you launch an Amazon EC2 instance, you can choose one of our AMIs with Windows Server and SQL Server. And in that case, your hourly instance cost includes the software licenses. That's why it's called License Included. Okay, let's compare running SQL Server on EC2 versus RDS. The most significant thing to notice here is that both environments are already familiar to you because you can use SSMS and SSIS in either case. The bottom four rows on this slide simply reflect the differences between having a managed service like RDS versus full control over the instance like EC2. With the managed service, you get automated backups and really simple support for high availability. But that convenience comes with somewhat less control over your instance. Now, as we go in through the rest of the slides, we're going to talk much more about always-on availability groups, and that's where the SIOS solution is really going to come in to help you. But if you choose RDS, it is just a checkbox. When you're deploying your instance in RDS, you can say, yes, I want multi-AZ redundancy. Okay, so let's go on. Now, when we talk about RDS, a key thing to point out here is that we have up to 30 databases per instance. You can use either Windows or mixed authentication with RDS. So again, you can connect SSMS to your RDS instance, and you can log in from your remote workstation, just like you would do to a database server in your own data center. Also, RDS supports TDE for encryption at rest. And another very interesting feature is we support native SQL backup and restore to and from the Amazon S3 storage service. So that's a brilliant way to get immediate off-site backup storage. Now, to bring your own license to RDS, you just submit a license mobility form to Microsoft to verify your licenses. And we provide that license mobility form on our site. And then Microsoft will email you and AWS to verify, and then you can deploy your application up to 10 days even before you submit the form. When you launch your RDS instance, you'll just choose a BYOL option instead of the license included option in a drop-down box that we provide when you're launching your instance. Okay, so that's a basic overview of RDS, but the gist of the core of this presentation is really about running SQL Server on EC2. So I'm going to jump into that now. And this slide is showing you an example of how to deploy SQL Server on Amazon EC2 with multiple availability zones. Now, keep in mind that what we call an availability zone is very different from what other cloud providers may call a region. We provide many regions around the world, but each region has within it multiple availability zones which are distinct floodplains and electric power grids and internet backbones, etc. So they are truly high availability for failover. Now, if you have SQL Server Enterprise Edition, which is shown here, you have you can do always-on availability groups and deploy them across two AZs. So when you do that, you can now have synchronous commit because we have very low latency between our two AZs. It's on the order of about 1 millisecond. And when you can do synchronous commit, that means you can do automatic failover. So this is a really brilliant design to set this up for always-on availability groups. But keep in mind that this is a basic capability with AWS out of the box. You can use our services like this, but it does require SQL Server Enterprise Edition. So if that's something that you want to not do and you want to stick with Standard Edition, that's where the SIOS solution comes in, SIOS DataKeeper, and Tony's going to be talking about that in just a moment. Okay, so let's go to the next slide. Let's talk about another example. Suppose you say to me, hey Scott, you know, this is great with two AZs, but I understand that those AZs are within tens of miles of each other. Well, we have a public server client, or we have, a government client, or we have our own rules that say that our data centers have to be, minimum distance 50 miles apart, or something like that. Or let's say that you're just really paranoid and you think that, if you did this in the East Coast, for example, there could be a nuclear event or an earthquake that might take out the whole East Coast. So you really want to go to another region. Well, that's doable also. So as you look at this diagram, what you'll see here is that we have two AZs in one region, which is our primary database server, but we're also doing backups, or we can even do online all the time, and we can have asynchronous commit to the second region, and that region could be anywhere in the world. Now, when you're doing asynchronous commit, don't even think about automatic failover. In that case, you have to do manual failover. But you should. Down at the bottom there between those, you see region A and region B, and we have a virtual private network between the two of them with an elastic IP address provided by AWS. So you can have a VPN between these two regions, and you can be doing the asynchronous commit over that, but you are going to have slightly higher latency. So that's an option if you really want to have extra redundancy. Now, a couple points about that. If you're doing DR and you want to have disaster recovery in that other location, in case you were worried about a whole region becoming unavailable, you could put DR in the second region. The first option where you had two AZs in the same region, that's going to reduce your recovery time objective and your recovery point objective. But if you try to run a hot standby in another region, that's either going to raise your cost if it's a hot standby, or if you keep it as offline, then you're going to have a higher recovery time objective and recovery point objective. So you've got two options there, sort of spanning a spectrum of greater expense or faster recovery time. Now, if you do the what I'll call just-in-time DR, that's the option where you say, yeah, we want to have a second region, but we're not going to have it deployed and running all the time because that might be expensive. Well, that's fine. We provide a service called AWS CloudFormation that lets you spin up that environment just in time, literally in minutes. You could restore a whole SQL farm with those instances, and then you would restore your data from backups in Amazon S3. So you might be looking at, depending on the size of your data, you could be looking at several minutes to several hours to get that site, that database back online. So that's up to you how you want to approach that. Okay, now this will be my last slide, and then I'm going to pass it over to Tony. I just want to mention some good news. If your secondary instance in either of those two previous architectures that I displayed, if it's truly passive, and if you have Microsoft Software Assurance and you're doing bring your own license, you can cut your SQL license costs in half. License mobility is a benefit of Microsoft Software Assurance. Note that your passive instance should not even be used as a read replica. It has to be really, truly passive. And there are many benefits to buying license-included SQL Server from AWS, but this isn't one of them. This passive license benefit only applies to BYOL. Now, another thing I'm going to mention is when you launch an instance in Amazon EC2, we only show you Windows Server and an option to include SQL Server Standard Edition, which would not support those two architectures I was just discussing unless you bring in the SIOS DataKeeper solution. But if you wanted to run Enterprise Edition on Amazon EC2, you have to choose an AMI, that's called an Amazon Machine Image, that we offer through our marketplace. So it is offered by Amazon, it's just located in a different place. But you can run SQL Enterprise and develop both of those architectures that I was showing you. So now I'm going to pass it over to Tony, and he's going to show you how you can use SIOS. Take it, Tony.
All right, excellent, great. Thanks, Scott. Let me go ahead and share out my screen here. So that was a great overview on the different SQL deployment and HA options that you have natively from AWS, and also what comes with SQL Server. However, I'm going to build upon that and show you another option that you have for creating a highly available SQL Server, and this is using the DataKeeper solution that allows you to actually deploy a full-blown failover cluster instance of SQL Server. So it's the best of both worlds. So you've got a number of different options, right? You can go with RDS, you can go with availability groups if you're okay with running SQL Server Enterprise Edition, and you kind of have to weigh the pros and cons of these different solutions. But there is a third option, and that's really what I'm going to be focusing on here, which is a failover cluster instance. So, in my discussions with SQL DBAs and IT administrators, most folks are familiar with deploying a SQL cluster, or now known as a SQL FCI, or failover cluster instance. But there are some limitations and some issues doing that natively up in cloud environments, and we'll talk about that in a moment. So, you really have to ask yourself, what are you looking to achieve? Do you need full instance level protection and HA for SQL Server, or is just protecting like your user databases, is that fine, right? So you can then decide, do I need a failover cluster instance or an availability group type thing? Do you want full control over your SQL Server instance? Are you looking to minimize cost using Standard Edition while at the same time achieving full HA and control? And do you want to leverage the technologies and the failover clustering techniques that you're used to, on-prem, you leverage that up in the cloud without having to try and do something completely new. And then also, most people want to reduce the complexity and administrative overhead that's involved in managing the HA. So, if you answer yes to really any of those questions, I think you'll be interested in learning, what DataKeeper can do and how it can really provide the best of both worlds. It can give you full protection and full high availability for SQL Server, give you more flexibility, more control, can reduce costs by using Standard Edition, and even span multiple availability zones and regions. So you have a lot of flexibility here. So if I move along, just to step back just a moment, so we're going to be talking about our DataKeeper Cluster Edition solution from SIOS Technologies. SIOS, we've been in the HA space for well over a decade. Used to be known as Steelite Technologies, been around since 1999. Global organization, thousands and thousands of licenses, protecting mission-critical applications in all types of environments, physical, virtual, and cloud. And what I'm talking about here today is really the concept of, I call it SANless clustering. And this is a great way to protect, not only SQL Server, but if you have other critical applications or services or applications, this type of a technology can really be used for everything. SQL Server is definitely the #1 kind of use case that gets deployed here with these types of clusters. But just keep in mind that you can protect other applications as well here. So going back to the term SANless clustering, if I asked most of you to draw on a whiteboard, draw me what a SQL cluster looks like, this is probably what you'd draw, something similar. You've got a couple of servers, you have some type of shared storage, whether that's, that would have been a fiber channel or an iSCSI SAN type thing. And that's how the native Microsoft clustering works. Now it's known as Windows Server Failover Cluster. It's a feature of Windows Server. You turn it on, you form a cluster, but in order to get that cluster to work and to configure it properly, you need some type of shared storage. Now there are a couple of issues with that. When you deploy your instances up in EC2, they don't have shared storage that can be used with a cluster. And even if they did, the whole idea behind a failover cluster is to eliminate as many single points of failure as possible, right? So that's why you have, multiple servers, in this case multiple virtual machines up in EC2. So you've got multiple servers, you've got redundancy at the network level, and why do you want your disk to be a single point of failure? So you want to have also redundancy at the disk level too. So what DataKeeper does, specifically DataKeeper Cluster Edition, is it allows you to deploy this quote-unquote SANless clustering architecture. And a more accurate term would be a shared nothing cluster, basically meaning that you don't have any shared storage between your systems. So, if you think back to the availability groups diagram that Scott covered, this is a similar architecture. You have different systems, they don't have any shared storage, but with availability groups it's database level replication, where with DataKeeper it's doing disk level replication, so it can protect the entire instance here. So it's the best of both worlds. You get the shared nothing architecture that availability groups brings, but you get the full instance level protection that a failover cluster instance provides. So what DataKeeper does is it replicates the drive letters between your systems, and we can support both synchronous and asynchronous replication. So this works great if you're deploying a cluster all within a region. You'd have different cluster nodes in different availability zones. You can even do this across different regions. In that case, as Scott mentioned before, you probably want to have some type of, VPN tunnel or some type of connection between the two regions for all of your traffic and to go through. So DataKeeper can do synchronous, which is generally suitable for high-speed, low-latency connections. So you would set up a synchronous mirror if you're doing this within a region between availability zones, or if you were doing this from one region to another, asynchronous would probably be more suitable. Now, as DataKeeper is replicating the storage, in this case the EBS volumes attached to these instances, we're keeping the data synchronized continuously in real time. So think of this as a software RAID 1 mirror, but going across the network. So whatever data gets written to node 1 on the left gets replicated in real time over to node 2 on the right. And this disk mirror is cluster integrated and cluster aware. So I'll show you in the demo here coming up, but we actually create a disk resource into the failover cluster, and it looks and it feels and it acts like shared storage. And if and when you have a failover scenario, whether it's planned or unplanned failure, and your SQL Server fails over to the other node, well, it tells DataKeeper to switch the direction of replication automatically. When the node on the left comes back online, the data will resync back automatically. It'll be a partial resync here. So this is just a standard, pretty common two-node configuration, but you're certainly not limited to two nodes. So maybe you want, a configuration where you have local HA within a region, and then you have replication to another node at a different region. So, a GeoCluster can really provide you with both HA and DR. So you kind of see the animation here. Let me go back. But in the event that failover takes place, the source and targets of replication automatically adjust. So that's the great thing about DataKeeper is the way that your cluster fails over and it looks and feels and behaves is the same as what you're used to. The replication is just happening transparently underneath the covers, and the source and targets are reconfigured based on where your SQL instance is running in the cluster. So you don't have to worry about managing your mirrors separately. That happens all automatically. Now the next slide I have is more specific to AWS. So this is a best practice configuration. When you're deploying a SQL cluster in EC2, this is what it looks like. You're going to have your two nodes. So here we've got node 1 and node 2. You want those in different availability zones for maximum availability. And in a typical on-prem cluster with shared storage, you would have had a quorum disk or a disk witness, which would be a small one that you carve out on your SAN, and both nodes can reach that, and it uses that as like your third vote towards quorum. But in this scenario, or any scenario where you don't have shared storage, you can't use a disk witness. So Windows Server failover clustering thankfully provides you with a feature called file share witness, where it can use a simple file share as a voting member of the cluster. So here this would just be another Windows system, can be a very small one. You just create a folder, right click, share it out, and give the cluster read-write permissions to that share. So ideally you want to have node 1, node 2, and the file share witness all in different availability zones for maximum uptime here. So this is when you're deploying and thinking about architecting HA for SQL Server, you want a failover cluster instance in EC2. This is what it typically looks like. So I know Scott mentioned some of the the pros and cons of availability groups, but I did want to get into that in more depth. That's typically the number one thing that I get asked is, okay, if I'm on SQL Server, it has HA features built in, what are the major differences? What are the things you need to consider and worry about? So we'll jump into that. And it changed a little bit. So there were some enhancements to availability groups in the latest SQL Server 2016. So we'll talk about what it looked like in 2012 and 2014, and then how it changed. Again, availability groups prior to 2016 was a feature only available in Enterprise Edition. So you had to make the jump, pay more for SQL Server just to get HA. Now, if you're in a situation where you're okay with SQL Standard Edition, maybe you don't need any of the features, the non-HA features that were provided in Enterprise Edition, but you still want HA, this is a great solution because Microsoft supports a two-node failover cluster using SQL Standard Edition. Now, of course, the gotcha in doing that on its own is you don't have the shared storage, and that's what DataKeeper, that problem is solved by DataKeeper. So this is a great way to deploy a two-node SQL Standard Edition failover cluster to get full instance level protection if you're doing this in an active passive fashion, basically with one license of SQL Standard. So very, very cost effective. Availability groups is not compatible with all applications either. So if you leverage distributed transactions and rely on MSDTC, that wasn't supported. There were some enhancements there in 2016, but still it's not a full solution. Availability groups also does have limitations on the number of databases per AG and AG per instance. And it's only protecting your user-defined databases, so your system databases aren't protected. So that means things like your SQL logons, your SQL agent jobs, you need to worry about and protect those on your own. If you think about what availability groups is doing, is it's two standalone SQL servers with glorified database mirroring happening on top of it. So you're managing two SQL servers. And that leads to the next bullet point about database administration. You're managing twice as many SQL servers as opposed to a failover cluster instance. You have one highly available instance of SQL Server that just so happens to fail back and forth between two different Windows cluster nodes here. And also, many times you're not just deploying a SQL Server. You've got an application on top of that that is also mission critical. And what if that application also has data that needs to be protected? So with availability groups, it's only going to protect the user-defined databases. That's it. With DataKeeper, as DataKeeper is doing disk-level replication, it can protect and replicate any data. It could be your SQL databases and logs. It could be PDF files or text files or some other type of data that is related to your critical application here. So those are the main differences. Again, it all comes back to really, with the SANless cluster, there are advantages in related to performance, to cost, to complexity, and to compatibility. So it's a win. It's a win all around. Now there were some enhancements with SQL 2016. Excuse me. So SQL 2016 did introduce the concept of a basic availability group with Standard Edition, but there are a number of limitations with that. It's essentially one database and one AG. So if you have any type of a significant deployment of SQL Server, it's probably not going to meet your needs. There were some enhancements related to distributed transactions, but there's still a lot of limitations with that you can read into and get more familiar with. So those are some of the major differences, but still there's a lot of things you need to consider. Are you looking to just protect certain databases, or do you want to protect the entire instance? Do you want to manage fewer instances of SQL Server, save money? Lots of reasons to look into a SANless cluster powered by DataKeeper here. So with that, I'm going to switch gears and I'm going to jump into a demo here and show you what this looks like. So for anybody out there who's configured a Windows or a SQL cluster in the past, you're already going to know 99% of how this all works. There's a couple of key differences here that DataKeeper is providing, and we'll get into that. And I'll show you how you can set up a DataKeeper mirror and have that be added to the cluster as a cluster disk with essentially a three-step wizard here. So here I have a typical two-node cluster. So my nodes are called SIOS 1, SIOS 1, and SIOS 2. Okay, so the first difference here is with the witness. So in your traditional failover cluster, again, you would have a disk witness. Here, I've configured a file share witness, and in my environment, I have three servers basically. I've got node 1, I've got node 2, and my third node is my domain controller in this case. So I've just decided to put the file share witness on my domain controller, but you can put it wherever it makes most sense for you. Again, in AWS, you ideally want to put node 1, node 2, and then the file share witness all in separate availability zones here. Now, if I look at my cluster roles, here this looks like your typical SQL cluster. I've got my virtual name, I've got my SQL resources, but here is where it's different. So in your typical shared disk SQL cluster, you would have what Microsoft calls a physical disk resource. This would basically be the shared LUN, and it would say cluster disk, S as an example. Well, in this scenario, there is no shared storage, so these instances were configured with matching drive letters and sizes. So here, my node 1 and my node 2 have equally sized S drives, and just for simplicity's sake, I've got all my databases and logs just in the same drive letter, but you can certainly carve it up as you see fit. I've got that here as part of my cluster role. So all these resources fail over together. Now if I look at the cluster storage, here I've got a couple of different DataKeeper resources. And again, these DataKeeper resources, they look, they feel, and they act like shared storage. But in reality, I have these matching drive letters and sizes between my two different instances. So this is just an EBS volume attached to each instance, and DataKeeper is performing the real-time continuous block level replication, and then it can be done either synchronously or asynchronously. And the way that you get this into the cluster is very simple. So DataKeeper does have a interface here. It's a simple MMC snap-in, and you can look at an overview screen, and I can see the different drive letters that I've got attached to my servers. What we're going to do here today is create a new mirror to replicate the R drive. So I'm going to do that by creating a job and give it a name. We'll call it R drive. And here's our three-step wizard. So here is where I'm first going to select my source. Next, I'll select my target, and finally my mirror options. So my source will be node 1. If you have multiple IP addresses attached to or interfaces attached to your instances, you can decide which network you would like to use for replication, and then go ahead and select the drive letter that you wish to replicate, and that's about it. Click Next, and step 2, I'm going to select my target, and it's automatically populated the screen for me. It's node 2, SIOS 2 is the target. It picked the appropriate IP address and the drive letter, matching drive letter here. And then finally, I can select my mirror options. So this is where you're going to decide if you want to go with synchronous or asynchronous. So here, these two nodes are within the same region in different availability zones. So I've got a high-speed, low-latency network between the nodes, as Scott mentioned. And I'm going to go with synchronous replication here. If this was replicating to a different region halfway around the world, then that's where you would likely go with async. And not to worry, you can always change the mode after the fact. You can really change all of these after the fact. We've got compression features, we've got throttling features. You typically aren't going to be turning on compression or throttling unless you're doing this, unless you're doing a geocluster config. If these are all within the same region, you're typically going to leave compression and throttling off and go with synchronous here. So after I've gone through this wizard, I click Done, and it's going to go ahead and create the new mirror and start the replication of the R drive, replicating the contents of node 1 over to node 2. And because DataKeeper is cluster aware and cluster integrated, it's asking if I want to register this with the cluster. So I'll say yes. I can see here that I've got this new mirror and it's already mirroring. I can see that node 1 is the source, node 2 is the target. So this is a great overview as to what's going on with my configuration here. Now, if I switch back to Failover Cluster Manager and when we now look at the storage, I've got this brand new DataKeeper Volume R, and it's sitting right there in the cluster's available storage pool. So at this point, you're just back to clustering 101. This DataKeeper disk resource looks, feels, and acts like shared storage. And when you're setting this up from scratch, what you're typically doing is you launch your instances, make sure they have matching drive letters and sizes, and then you configure your cluster. So you turn on the failover clustering feature, you go ahead and form your empty cluster, make sure it passes cluster validation, and then you install DataKeeper afterwards on the nodes, which is a simple, we didn't go through it here today, but it's a simple setup.exe. You click next a couple of times and you reboot. So DataKeeper's filter driver can activate upon reboot. After that, you go through and you create the DataKeeper mirrors as we did here today. And typically the final step with a SQL cluster is the actual installation of SQL Server. So you go ahead and fire up the SQL installer, select the option to install a clustered instance of SQL, follow the wizard, and when you get to the screen that asks you about storage, you check the box next to the DataKeeper resource that you want to use. So you can check the box next to DataKeeper R as an example. Now when I fail things over, again the behavior and the failover is still the same. So if I want to fail over my SQL instance from node 1 to node 2, I'm simply going to right click and we'll move it to the best possible node, which in this case is the other node in my 2-node cluster. And just like you would expect, it's taking resources offline on node 1 and it's bringing them back online on node 2. As part of this process, it's failing over the DataKeeper volume resource as well, which is telling DataKeeper under the covers to switch the direction of replication. So now this S drive is replicating from node 2 back to node 1. So again, the failover took just a few moments like you would expect. Just to kind of show you that DataKeeper actually did switch the direction of the mirror. If I go back here and look at my overview screen, I can see here that S is now where it used to be a source on node 1, now it's a target, and vice versa for node 2, where it used to be a target, now it's a source. You can also look at any of these jobs and get specific information and see who's source, who's target, and here's my S drive. SIOS 2 is the source, SIOS 1 is the target, and I can see state information and IP endpoints and all of that. So that's really the beauty of DataKeeper here is you can leverage all of the SQL HA knowledge that you've gained over the years by deploying Windows and SQL clusters. You now can deploy this up in EC2 You don't need the shared disk requirement, but you can really get superior HA at a lower cost with standard edition, with a lot less complexity and a lot less limitations. So basically, you get all the bells and whistles of a typical SQL cluster, but you no longer have the limitation of shared disk here. So let's go back. Let me switch back to the slides here. So just to kind of wrap things up here, and then we'll open it up for Q&A. Again, with DataKeeper, just in general with SQL Server on AWS, and you've got a couple of different options as to how you deploy your SQL Server and how you make it highly available, whether that's RDS, the managed service, whether it's SQL in EC2, and when it's in EC2, you can then decide, well, do you go with availability groups if you want to make the additional cost, but you have to be aware that there are a lot of limitations, and it's not full HA for your SQL Server. Or do you want to go with a failover cluster instance, which is full SQL level protection, but DataKeeper can then solve and provide you with the ability to get rid of the shared disk requirement here. A couple other things I just want to mention is SIOS has just launched an AMI, or Amazon Machine Image, with DataKeeper, so you can find that in the marketplace. And in the near future, you'll also have there will be a quick start template launched, and that will be very, very nice, because you'll be able to basically with a single form, one click, launch a fully configured failover cluster instance of SQL Server with DataKeeper. So very exciting. So with that, I don't know, Scott, if there's anything else you'd like to add, or Greg, we'll turn it back over to you and see what questions are out there.
Okay. Scott, do you have anything else you want to add, or you want to just jump into the questions?
No, let's jump into the questions.
Okay. All right, sounds good. And if everybody out there listening, if you have questions, just use the question area in the controls and just type your question in. We'll just take them one at a time. So I guess one question is related to the DataKeeper. Just wondering what versions of SQL it supports, which operating systems?
Oh, great question. So DataKeeper actually doesn't have any restrictions on the version of SQL Server. If we think of what DataKeeper is doing, DataKeeper is replicating various Windows drive letters on your Windows systems. So you tell it which drive letter you want to replicate, and whatever data lives in that drive letter is going to be protected, whether it's SQL data or, again, PDFs or images or what have you. So DataKeeper works with any version of SQL Server. You just need to make sure that the version of SQL Server that you want to run in your cluster is compatible with the version of the OS that you're going to be running. I mean, for example, I'm not sure you could cluster SQL 2016 on Windows Server 2008. So you just have to look at the Microsoft support matrix there. But as far as DataKeeper support for Windows Server, DataKeeper goes back all the way back to Windows Server 2008 R2.
Okay, great. All right, another question that came in is just wondering about, is there an easy way to test this out on AWS without spending a lot of money? So just wondering, can they set up what's actually available for both DataKeeper and AWS to kind of kick the tires?
Yeah, definitely. So you can look for the DataKeeper AMI there. SIOS also, we do have evaluation licenses, so if you want a free trial of the software, we can certainly provide you with that. It's a fully functional copy of the software. It just has a time-based license key, and if you're interested in testing out DataKeeper yourself, you can reach out to SIOS, and there's a form on the website where you can request eval software and try it out yourself.
Okay. Then Scott, is there anything they need to know differently?
Yeah.
Sorry.
I'll just add one thing there. We have a free tier in Amazon EC2, but the free tier is not sufficient for SQL Server. So it provides what we call as we have over 40 different instance types, and one of them, the free tier, provides the T2.small, and those are not adequate for SQL Server because they only have 1 gigabyte of memory. So they are useful for doing ASP.NET experiments. You could write you could deploy IIS and run a tiny website on the free tier, and it could be connected to SQL Server RDS or SQL Server on EC2 on a different instance type, and you could certainly you take advantage of the free trial of SIOS DataKeeper on that.
Okay. All right, the next question that came in is just related to DNS requirements. Just wondering, can you just talk about how the whole DNS works and how the IP addresses work if it fails over? Is there something that you do on the back end to make that work, or is that all automatic?
Good question. So when you're deploying a cluster like this in EC2 and your nodes are in different availability zones, your nodes are on different subnets. So you have this multi-subnet SQL cluster. Essentially what you're going to have if you dig down into your cluster, your SQL cluster role underneath that network name, there's actually going to be two virtual IPs, and one of them will be online at any given time based on which node in the cluster is online. So there'll actually be two IPs registered, and what you're going to want to do in this scenario, just like you would in the past with like a geo cluster, is you'll want to use the multi-subnet failover equals true flag in your connection string. That's the Microsoft recommended way of dealing with a multi-subnet SQL cluster.
Okay. All right. Another question here is related to, again, the DataKeeper replication. So we're just wondering, does it replicate the entire volume, or can you pick and choose which files are replicated? Can you?
Good question. Yep. So it is volume level. So you can get as granular as a drive letter. Whatever is in that drive letter will be protected. So you don't have the ability to pick certain files or folders. You say, I want to replicate D or E or F, and you can decide, well, maybe I want to replicate D, but I don't want to replicate E. So a best practice here is, especially with SQL 2012 and newer, where TempDB can now live on a local drive that doesn't have to be a part of the cluster, is you would want to separate TempDB to a different drive letter and then don't create a DataKeeper mirror for that. I mean, you can, but you're just creating unnecessary replication traffic because TempDB gets thrown away and recreated upon failover anyway. So yeah, you can carve up your drive letters as you see fit, and you can decide which drive letters get replicated versus which drive letters don't.
Okay. All right. I guess both Scott and Tony, can you just talk about sort of patching, how that works at the EC2 VM level versus the OS level versus DataKeeper, SQL Server? How do people actually do that with having multiple machines out there?
Okay, so I can definitely tackle how's that handled at the cluster, the kind of the Windows level and up, and then Scott, I'll let you talk about what happens, I guess, at the infrastructure, that kind of level, if there's anything going on there. But just like on-prem clusters, you typically are going to do your patching in a rolling fashion. So let's just go back to our simple two-node configuration where you have node 1 and node 2, and say node 1 is the active node at that point in time. So generally speaking, you're going to apply your patches and your updates to the passive node in the cluster. Reboot it when it comes back online. Then you would fail over your SQL instance to the other node in the cluster, and then you would go back and patch node 1. And then once that's done, you can decide do you fail back or not. In a best practice scenario, both of your cluster nodes are identical in every way. So in theory, it shouldn't matter which one is active at any given time, but you can decide whether you move it back to the original node after the patching or not. But yeah, long-winded way of saying just do rolling upgrades.
Okay, this is Scott, and I'll add to that. Good answer, Tony, but I'll explain also the view of patching in Amazon EC2. From the AWS perspective, keep in mind that we don't do any patching of the OS once you launch an instance. That instance is yours, and we don't have the capability to log into that OS with the administrator account. That's yours. Now, having said that, we do patch all of our Amazon machine images that offer Windows Server. So if you're doing a license included launch of an instance, that has Windows Server, and it can optionally have SQL Server Standard, or as I mentioned from our marketplace, you can get SQL Server Enterprise. All of those are provided by AWS. Before you launch it, we are keeping those patched. Within 5 days after a Microsoft Patch Tuesday, we are updating those AMIs. So we're updating them basically monthly. But having said that, once you launch that instance, you may find that it hasn't been patched recently, and maybe Microsoft just came out with new patches. So you're going to see that little, if you log into the GUI through RDP, you're going to see that little pop-up toast message from Microsoft Windows telling you, hey, there are patches available. And you have to choose how you want to deploy those. We definitely don't recommend logging in and clicking on the GUI with the mouse to do that. You want to do as much as you can through DevOps, and we provide some very powerful features for that. First of all, you can use PowerShell very well with AWS. It integrates very well. But for things that's for Windows-oriented things, PowerShell, but for AWS infrastructure-oriented things like launching the instance and other resources like RDS databases, etc., we recommend that you use CloudFormation. Now, and apart from that, you can use our EC2 Systems Manager, which has the capability to run a PowerShell command on an instance, and so you could take advantage of that for rolling patches like the scenario that Tony was talking about.
All right, great. Okay, another question that came in is related to scaling up the VM, so adding more resources when there's a need and scaling back, and just wondering how does that work, and does that change if you have a cluster in place? Do both machines have to have the exact same resource on both ends to still work?
Sure, I can address that from the cluster side, definitely. So, best practice, you want to have your cluster nodes identical in every way. Same CPU, same memory, same everything. That's not a requirement. I mean, you could have one cluster node with more CPU and memory, like a bigger instance size, and you technically could have the second node could be a smaller VM basically. You just have to understand that if you fail from node 1 to node 2 and now you're running on the smaller instance, that things might not perform as they did on the other node. So, but technically that can be done. As long as your your Windows cluster passes cluster validation, Microsoft considers this to be a fully supported cluster. From a disk perspective, the drive letters and sizes need to match. So, the follow-up question that I get here is, well, what if I, need to expand my drives? You most certainly can do that. It's a simple procedure where you basically just pause the mirror, you expand your volumes, and then you click a button to resume the mirror, and it does a delta resync. So you can change that, grow or shrink your disk sizes after the fact as well.
Okay, great. Scott, anything to add on that?
No, that was a great answer.
Okay, all right, great. All right, another question that just came in, and I'll just read as it came in. It just says, how does this product compare to Storage Spaces Direct in Server 2016?
Sure. So, Storage Spaces Direct in 2016 is something. Again, it comes down to cost and complexity. It's something that's generally going to be only available in the data center edition of that, and there are also some pretty strict requirements as to how it actually gets deployed. So we can probably follow up with some more specific information there, but it's going to come down to cost and complexity as well.
And this is Scott. I'll add one thing to that. We have a white paper on the AWS site that explains how to use storage spaces in 2012 R2, which would also work in 2016, but that's not Storage Spaces Direct in 2016. We do not yet support Storage Spaces Direct on Amazon EC2.
Okay, well there you go.
Okay. All right, another question that came in, it's, I guess, related to what we're talking about. It's more about DR, and they're just wondering, can they have an on-premises machine and use DataKeeper to replicate the data to AWS for like a DR situation?
Absolutely, absolutely. So DataKeeper is server and storage agnostic. So I mean, you most definitely could have a configuration where one node is in your data center and a different node is up in AWS. You just want to make sure that you have the appropriate network connectivity established between your site and AWS. And make sure you have enough bandwidth, because DataKeeper is going to want to replicate the data as fast as you write it. So if you don't have enough bandwidth, one of two things will happen. If you're in synchronous mode, then that's going to slow down your writes, and if you're in asynchronous mode, well, your mirror might never catch up, because let's say you're writing, if you're on average writing at 20 megabytes per second, but your connection only can push 10 megabytes per second, you do the math there, it's never gonna catch up. So understanding, regardless of the environment that you're in, understanding your data's rate of change versus the bandwidth that you have between your source and targets, that's probably the most important thing to understand and consider. And you can find that out by looking at perfmon. Look at your logical disk write bytes per second, and it'll tell you how rapidly you're writing to disk.
Okay. All right. The next question is related to the number of nodes in the cluster. They're just wondering, is it limited to 2 nodes, or can you have additional nodes beyond 2?
You can. So the 2-node limitation is it's a Microsoft limitation when you're using standard edition. So if you want a 3-node configuration, in that scenario, if you want a 3 or more node SQL cluster, then you would need to make the jump to Enterprise Edition. But there are ways, that you can architect things a little bit differently. You might have maybe that 3rd node, you don't need to have that in the cluster. Maybe you want to replicate to it to protect your data. So that 3rd node could be a non-clustered node. DataKeeper would replicate the data in real time still. But if you lost, your cluster, all your data would be sitting there. You'd have to, manually start up SQL Server on that node. So again, this really all comes down to your recovery time and recovery point objectives, and then you can decide what makes most sense. But yeah, Microsoft supports many more nodes in a cluster. DataKeeper supports that as well. We support multi-target replication. It's just that 2-node limitation is on a SQL Standard Edition cluster.
Okay. All right. The next question here is just, is there any limitations of size of database, and does that impact the latency for moving data in AWS from one group to, or one zone to another zone?
No. So the size of your data set really only matters when you first create the mirror, because it's going to want to do an initial sync. But from there on, really what is most important is how rapidly that data is changing, and making sure you've got sufficient bandwidth. So you could have, a 10 terabyte database that's mostly read-only and is not changing a lot, and that wouldn't create very much replication traffic at all. Versus another scenario where you could have a very small database that has a lot of, changes, and that would use up more bandwidth for replication. So really the rate of change is what is most important here.
All right. Is there any other questions out there? If somebody else has additional questions, feel free to type them in, and we'll take a few more questions. As we're waiting for new questions to come in, is there anything else that either Scott or Tony want to add or discuss further?
No, I just want to. Go ahead.
Well, I was going to mention that the cost of DataKeeper is, I think, very affordable. If you're looking at doing the multi-AZ deployment and you think you need to use, for that you would need SQL Server Enterprise Edition. If you look at the cost of the SQL Server Enterprise licenses, and whether you're doing a BYOL or whether you're running with license included in Amazon, definitely want to compare that versus the cost of SIOS DataKeeper, which I think is very affordable. And then you might be able to stay on SQL Server Standard Edition as long as the the RAM requirements and as Tony just mentioned a second ago, the number of nodes that you can have. If you need 3 nodes, or if you need more than 128 gigabytes of RAM, then you are looking at certainly you do need Enterprise Edition then.
Yeah, and from what I've seen working with customers, I mean, oftentimes two copies of DataKeeper can cost you less than just 1 core license of SQL Enterprise. So, you start talking about, most people are deploying, if you're on SQL Enterprise or just bigger SQL servers in general, you're typically running on more than 1 core. So, it's significant cost savings if you can do this on Standard Edition as opposed to making the jump to Enterprise. But yeah, I just want to thank everybody for their time. If you want more information, please visit, you can visit our website at us.sios.com.
Okay.
Greg?
Yeah, we've got a couple more questions that just come in.
Oh, okay. Great.
One question, I'm not sure if they're confusing the technologies, but I'll just ask as the question came in. It just says, how can DataKeeper help with the quorum drive for always on witness?
Okay, so if we recall back to and I can actually bring up the diagram here again, and if you want, I can share my screen again.
Yep.
There we go. Okay, so if we go back to this diagram here, in this type of a configuration, you don't have a disk witness, or it used to be called a quorum disk. You're going to use a file share witness instead. That Windows system where the file share witness resides, there's no DataKeeper installed. DataKeeper is only installed in this diagram on node 1 and node 2. The file share witness is just a folder you create on that Windows system and right-click on it and say share, and you give the cluster read-write permissions to that folder. So in this shared nothing or quote-unquote SANless type of an architecture, you don't have a quorum disk or disk witness. You have a file share witness instead.
Okay, another question is, it says, can you replicate the ephemeral disks on EC2 instances? And if so, what happens if the server is shut down? Do you lose the disk?
Yeah, so I wouldn't suggest doing that. You want to have persistent data, because then if you reboot or if something happens to that node, if the disk goes away, that's basically going to break your mirror. And I don't think you would want to put your mission critical SQL Server data on a disk that goes away when a system goes offline anyway. You're just asking for data loss there. So the way that I see customers deploying this are with EBS volumes that persist through reboots and shutdowns and all of that. Because also then if the disk goes away, even if let's say it's the standby disk that went away, when it comes back online, you would have to reinitiate a full resync of the entire data set. So there are lots of issues with that, from a just data preservation perspective, but also it has availability impacts because you'd have to wait till the data would sync again before you could fail over. I would not suggest doing that.
But you can use our ephemeral storage drives for TempDB.
Yeah. Yes.
That would be the recommended way to do that.
Yeah, I definitely agree. Yep.
All right, great. Well, there's other questions. We're actually out of time, so what I'll do is I'll forward those questions on to Tony, and he can kind of take some of these offline. But I want to thank Scott and Tony, and also thank SIOS for sponsoring today's event. To all of our listeners out there, don't forget to visit SIOS website to learn more about their solutions. The webcast was recorded, and you'll receive a follow-up email with links to view the archive. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux for MS SQL Tips. Thank you for attending, and have a great day.